So probabilistic approach for acceptance samplings. So the probability distribution, specifically the discrete probability distribution, play a very important role in acceptance samplings. So in my previous lecture, I have discussed the binomial distribution. Poisson distribution is also, you can also use Poisson distribution, but in this lecture, I am also going to show you that when you will be able to use Poisson distribution and when you will be able to use binomial distribution. Poisson distribution is basically a limiting approximation of the binomial distribution. So all the four properties of binomial distribution are fulfilled in Poisson distribution. Because in binomial distribution, we say that the number of trial will be fixed and there are only two possible outcomes, if effective or defective, acceptance or rejection. So similarly, the same property is also fulfilled in the Poisson distribution. So Poisson distribution also using the approach of independent variable. The trial will be independent, not dependent. Okay. So why the Poisson distribution is different from binomial, and why because this is more similar to binomial distribution, that is why we are writing as a limiting approximation of the binomial distribution, because in Poisson distribution lot size will be very large. In binomial distribution, the lot will be very small. It will be much smaller than the Poisson distribution. So n is very large and approaches to infinity. You can see this is approaching to infinity. So when this is the situation, you need to use Poisson distribution. Another indicator in order to use Poisson distribution, in Poisson distribution, P which is the probability of success, which will be very small and it will be approaching to 0. While the P of binomial will be very high. It will be near to 1 or it will be in the middle. But in the Poisson distribution, the probability of success will be approaching to 0 and the lot size will be very high in the Poisson, while the lot size will be smaller in binomial. For example, there is a very simple example. For example, when we throw a dice, so normally in the dice we have 6 possible outcomes. It will be 1, 2, 3, 4, 5 and 6. Because when we throw it, maybe you will get 1, maybe you will get 2, 3, 4, 5, 6. Let's suppose we have a special die and the sides in a die will be 100, let's suppose. So if there are 100, so let's suppose in this normal die, the probability of getting a 6 will be 1 by 6. So you can see this P is very high. This P is approaching to 1, the total probability. But if I throw a 100 side die, so the sample space will be 1, 2, 3, 4, 5, 6, 7 and it will be up to 100. Okay, so the probability of getting a 6, let's suppose in this example, will be 1 by 100. So in this case, the probability of success will be approaching to 0. So the probability of Poisson distribution, of success probability of Poisson distribution is very small and approaching to 0. But you can see in this example that n is very, this is our n is very large. Okay. Similarly, if the slight number on a specific special dice are 1000, then the probability will be further reduced and it will be approaching to 0. So these are the identification. You need to use these indicator in order to use binomial or in order to use Poisson distribution. So the Poisson distribution, which is also a discrete probability distribution, this is the probability density function. Okay, this is lambda and lambda is equal to, this is also called mean. Okay, this is the mean or average and this is equal to n into p, and the p, we already talked a little bit about the p, probability of success. So where px is the probability of x occurrences in an interval, lambda is expected value or mean value of occurrences within an interval. So if we have n value and p value, we will be able to easily calculate the mean. E is the natural logarithm. Poisson is also probability distribution of rare event. So now I'm just going to show you that how we will use Poisson distribution in order to accept a sample. So Poisson distribution, let's suppose in this simple question, 10% of the tools produced in a certain manufacturing process turn out to be defective. Find the probability that in a sample of 10 tools, chosen at random, exactly 2 will be defective by using the binomial distribution, the Poisson distribution. So in this example, I'm just going to show you that how you will use binomial and Poisson. So when you solve it, the answer will also be a little bit similar. It will be not too much different from the binomial distribution. So now they already mentioned that 10% of the tool produce in a certain. So probability of defective is 10% or 0.01. You can also write this. So the probability of effective will be 0.9. It means they can produce 90% good item. And what is the sample size? Find the probability sample of 10. So the sample size is 10. So they already mentioned this 10. So in order to calculate lambda exactly 2, now they are asking you that what will be the probability, find the probability that a sample of 10 tools chosen at random, exactly 2 will be defective. So if you want to use binomial, so x will be 2, x will be 2. So n is 10, we already know, and probability of defective is 0.01, 10C2, and probability of effective is 0.9, power 8. Why power 8? Because this formula is 10 minus 2. So this will be 8. When you simplify it, 0.193, which is 0.19. 0.19. And if you want to use Poisson distribution, which is a limiting approximation of binomial distribution, so you need to calculate lambda. We have already calculated, n is 10 and p 0. When you multiply this, 10 into 0.01, it will be equal to 1. Okay, so we have already calculated lambda. E power, because they are asking for exactly 2 will be defective. So we want to calculate this, 2 will be defective. So e power lambda value is minus 1 into 1 power 2 divided by 2 factorial is equal to 0.1839. So you can see this is 0. So this is approximately 0.19. So 0.19, this value and this value are same. But you need to understand that where you will be able to use Poisson distribution and where you will be able to use binomial distribution. So I hope that you understand this, and in the next lecture I will tell you that how you will use hypergeometric distribution and how you will use Microsoft Excel in order to calculate Poisson, binomial and hypergeometric distribution. Thank you.